Okay, so let us begin with the new exercise introduction, that is 10.2 introduction. So in this basically we will be studying about addition of vectors, how we are going to add them, how we are going to use scalar multiplication, what are the types in addition and all. So basically in addition there are of two types. One is a triangle law of vector addition, another is parallelogram law of vector addition. This you have already come across in first year physics. Just we will take a look. Okay, so I am a person, so going from point A to point B. From point A to point B I will be traveling, and that I am going to consider it as vector AB bar. Vector AB bar. Then the same person will travel from point B to point C. Okay, this vector I will consider it as BC bar. So now the addition of these two vectors is given by this straight vector, which is AC bar. Now if you see here, this is nothing but, in physics, A to B then B to C is nothing but the distance traveled by the body. It is the longest, it is the path covered by the body, however it is going. But AC is the shortest distance between the 2 points. The shortest distance between the 2 points is nothing but known as displacement, and the displacement vector will give you the addition of AB bar and BC bar. Now let us just see here. Now what I will do is, I'll just take what we came to know. AC bar is nothing but the addition of these two other two sides, that is AB bar plus BC bar. Now what I'll do is, from negative of a vector, previously in this video we have seen negative of a vector. From negative of a vector, what happens if you interchange the direction, then you have to add a negative symbol to it, which is equals to AB bar plus BC bar. So therefore, now if I transfer this to the other side, it will be like 0 is equals to AB bar plus BC bar plus CA bar. It means what? If I am going from point A to point B, then from point B to point C, then from point C to back to the point A, if I am completing one complete circle, or if I am starting from the same point and coming back to the same point again, it means what? It is one complete circle or one complete position where I am going to come back. It means what? Displacement is 0. Therefore this equation leads to your answer, that is, if the sides of the triangle are taken in order, then their resultant will always be 0, because net displacement will be 0, that is AB bar plus BC bar plus CA bar will be equal to 0. So this is nothing but known as triangle law of vector addition. So this is known as nothing but known as triangle law of vector addition. Now let us understand this next topic, that is parallelogram law of vector addition. Okay, for this I'll give a quick example which won't take much of time. So these are two banks of the river. This is the banks of the river, and of course in the river water will flow in one single direction. Suppose I consider the flow of water is downwards, so therefore one of my force is in this direction. Now what I will be doing is, I will put a boat over here, which boat means it will of course have an engine for it, which will throttle in the direction I want to. So therefore I want to go from this bank to this bank of the river. It means what I am going to do, I am going to apply the thrust on the boat. It will nothing but move in this direction. I want the boat to move in this direction. It means I want the force to be applied in this direction. One force is the natural force, which we don't want actually, it is downwards, and the other force which we want is perpendicular to that force actually. This boat will neither take this direction nor this direction, but it is just the sense of knowledge that this boat will of course trace a trajectory path somewhere like this. You want to go here, but due to a correction you will reach over here itself. So therefore what happened now? So did you observe here, my force was, one force was in the downward direction, one force was in this direction, the resultant force whatever I got was in this direction. That is because that is why we call this as parallelogram law of vector addition. So therefore I'll just put up the parallelogram. Here is the parallelogram which I had told you. So just see here, I'll explain this in diagram itself. Suppose O is the origin, and let me explain the properties of parallelogram. The opposite sides are equal and the opposite angles are equal in a parallelogram. I hope you all know that already. So therefore this is OA. Now OA is one vector represented along one side of the parallelogram. OB is another vector represented by another side of the parallelogram. Then the sum of these two vectors is given by the diagonal which passes through the center. Of course the diagonal will pass through the center. The sum of these two vectors which are represented on the adjacent side is given by the diagonal of this parallelogram. Now if you observe, just forget about this upper part, just take a look here below. Now does this look at like a triangle for you now? O, C and A, this is a triangle, right? Now OA bar and AC bar, this is nothing but B bar. Why it is B bar? Because opposite sides are equal, therefore this is A bar, this is B bar and B bar. So therefore A bar plus B bar, does this not state the triangle law of vector addition? So that is why these two laws, that is triangle law and parallelogram law, go hand in hand. So therefore let us check out the definition. If we have two vectors represented on adjacent sides of the parallelogram, then their sum of the vectors, that is A bar plus B bar, is represented by the diagonal of that parallelogram itself, and this is nothing but known as parallelogram law of vector addition. Okay, now let us see properties of vector addition. Basically you have two properties, I will be giving another one. So property one is commutative property. For two vectors, if you have A bar plus B bar is equals to B bar plus A bar, so this is of course satisfied. For the property 2, we have associative property. For any three vectors A bar, B bar and C bar, what you have is A bar plus B bar plus C bar is equals to B bar plus C bar plus A bar. That is nothing but what he is trying to tell us is, if you change the association also, you will be getting the same result. That is what the associative property means. So this is your property 1. Property 2, the additional property is, suppose A is any vector and 0 bar is a 0 vector. 0 vector is the vector which has magnitude 0. So therefore if you add a vector A bar to a 0 vector, your answer will be vector A bar itself, eliminating 0 vector. Of course it holds with the vice versa as well. So that is the properties in vector addition. Now let us study the new topic, that is the multiplication of a vector by a scalar. Okay, so before we begin this exercise, before we begin this topic, I'll give you a small work. See, suppose you multiply two numbers, you will get a number itself, right? Now if I multiply vector into vector, this is in the later part, then the output will be vector itself. But what happens if you multiply a vector with a scalar? Will the output be vector or the scalar? Just think over it. I'll be answering it in the later part. Stay tuned for that. Next one, let us come back to this topic where he is telling multiplication of vector by a scalar. Suppose you have one vector which is of this format. This is vector A bar. A bar vector has initially two parts within itself. Now if I want 2A bar, it will be twice of whatever the A is there. So A has basically two parts. It means 2A will be having, of course, 4 parts. So 1, 2, 3, and this is fourth one. 1, 2, 3, 4. Yes. Here we have 4 parts, whatever is required. Okay, 4 parts we have here. That is 2A bar. It means what? It is going to increase whenever I am going to increase the scalar over here. Whatever I am using the scalar, that will be increasing. So therefore if I take it like half of A bar, it means what? 2 parts are there in A. It means only 1 part will remain. So therefore this is nothing but half of A bar. Now next one, if I take minus A bar का मतलब क्या होता है? It is basically A bar, but in the opposite direction. You already know this. So therefore it will be in the opposite direction exactly 2 units, that is minus a bar. Next one, we'll consider minus of let us say half a bar. What it will be half a bar? This is in the positive direction, matlab in the positive direction, and this negative half will be in the other direction. So therefore a single part with negative side, that is to the opposite side of the initial point. You can just mark a dot over here. So this is nothing but multiplication of a vector to a scalar. So here is the scalar. Scalar ka matlab kya hota hai? Which has only magnitude but not direction. So therefore this is your scalar, this is your vector which we have multiplied, giving you the resultant as this itself. Okay, so let me answer this. Whenever you multiply a vector by a scalar, what you are getting here? You just multiplied a scalar to a vector. Did the direction of this vector go somewhere? Did it vanish with a magic? No, of course it is still a vector. So therefore vector into scalar is always a vector. Very good question for 1 marks. It may be asked, may not be asked. It is for your personal knowledge. So this is multiplication of scalar by a vector. Now let us see components of vector. So this is the basics of whatever is required, that is I, j and k. You will be hearing them for the first time here. So let us consider 3 coordinate axes, namely x, y and z. So here you have x, y and z. Now I'll consider 3 different points on 3 different axes. Now tell me what will be the point on x axis is, it will be 1, 0 and 0. Now what will be the coordinates on this? Z comes always last, so therefore 0, 0, 1. So this is 0, 1 and 0. So suppose this is O, this is A, B and C. Now tell me what is the distance of OA? Is it not 1 unit, because we have considered here 1, and OB is what? It is 1 unit. Now tell me, if I consider a vector OB bar, if I consider vector OB bar, OA bar and OC bar, what it will be? It will be nothing but the magnitude of these vectors will be 1. Of course it will be 1, right? Because the distance is what? It is 1 itself. So therefore the magnitude will be 1. So therefore whatever I am writing over here, this is important. Now OB vector is 1. Then if the magnitude is 1, then we call it as a unit vector. Therefore I is nothing but the unit vector, I is nothing but the unit vector along x axis. If you observe here, this vector is nothing but I cap, we call it as cap is given only for unit vectors. Please remember that. Now OB is j cap, which is the vector OB bar that we represent, and OC bar is nothing but k cap. So now I, j and k, I cap, j cap and k cap are nothing but
the unit vectors along the axis
I, cap, j cap and k cap are the unit vectors along these 3 coordinates, that is ox, oy and oz. So this is nothing but components of vectors. We call this as components of vectors. Now just let us see some important properties what we can extract from the 2 vectors. मतलब अभी तक तो आपने सिर्फ theoretically पढ़ा था कैसे 2 vectors को ऐड करते हैं. Now we are going to show you how you actually apply them in sums. Okay, suppose you have vectors a bar and b bar. A bar is x1, y1, z1, I, j, k. This is x2i plus y2j, z2k, the same old fashioned vectors. Now the sum of the 2 vectors, the sum of these 2 vectors is given by the corresponding elements are added. You see, x1 plus x2i, y1 plus y2j, z1 plus z2k, only that much. Okay, only the thing is just go on adding them I, j, k values and done. And the difference means the subtraction of 2 vectors. Just replace negative sign in this equation, that is corresponding elements you are going to subtract. So that is nothing but the difference. Now for 2 vectors to be equal, अगर 2 vector को आप equal दिखाना चाहते हो, then what you can do is x1 is equals to x2 कर सकते हो, that is y1 is equals to y2 and z1 is equals to z2. So basically ये दो क्या corresponding values है, so these all should be equal to one another, then only you can say that the two vectors are equal. Okay, so let us move on to the next one. So fourth one, what we have here, we have some vector a bar is equals to xi, yj and zk, some vector मान के चलो, और lambda a bar will be what, lambda xi, lambda yj, lambda zk. It means what, if you are multiplying lambda in common, you can multiply it throughout the equation itself. Now let us see the fifth property, it is composition of many functions. Now this k and m are two constants and a bar and a bar are the vectors, then you can take it common outside, and k m a is there, k and m are constant. First you can multiply k and m, afterwards you can multiply it with the vector a bar. So now k a bar plus b bar, which is equals to k a bar plus k b bar. So this is nothing but all the important properties, and these properties you will be using in your exercises to solve the sums. Okay, so let us solve example number 6. So here we have, they have asked us to find the unit vector in the direction of vector this. So I will write the vector over here. Solution, vector is what, a bar is equals to 2i plus 3j plus k. So is this your vector? And cap is there, that you will be writing the unit vector in the direction of the same vector, in the direction of this vector itself. How it is given is, it is given by vector divided by modulus of the same vector. किसके डायरेक्शन में हम यूनिट वेक्टर निकालने वाले हैं, इसके डायरेक्शन में ना, तो इसको नीचे का इसका मॉड लेके डिवाइड करना है, and the ऊपर वाला thing is the vector itself. Now tell me how to find mod of a. Mod of a is given by vector a bar is what, a bar is 2i plus 3j plus k, correct? So mod of a bar is root of x square y square z square, correct? So x square is here 2 square, 3 square, 1 square. Tell me 2 square is 4, 3 square is 9, 9 plus 4 is 13, 13 plus 1 is 14. So root of 14. So this is nothing but your mod a. Now what is the formula? A bar divided by mod a. Now the unit vector is equals to a bar divided by mod a bar, right? Correct, right? So what is a bar? 2i plus 3j plus k whole divided by, what is mod a? mod a क्या मिला आपको? रूट ऑफ 14. ये सब लोगों को डिवाइड करके छोड़ो, 2 by root 14 i plus 3 by root 14 j plus 1 by root 14 k. So this is nothing but the required unit vector in the direction of the vector this. Now let us solve example number 7. So in example number 7, what he is asking us to do is find a vector in this direction whose magnitude is 7 यूनिट्स. एक ऐसा वेक्टर ढूंढ के बताओ जिसका मैग्नीट्यूड 7 यूनिट्स आना चाहिए, ठीक है? एंड दैट टू इन विच डायरेक्शन? इन डायरेक्शन ऑफ दिस वेक्टर इटसेल्फ. सो देयरफॉर हाउ वी आर गोइंग टू डू? फर्स्ट, अपने को तो 7 यूनिट वाला मैग्नीट्यूड वाला वेक्टर तो मिलेगा नहीं आसानी से. सो व्हाट वी विल बी डूइंग इज, फर्स्ट सॉल्यूशन विल फाइंड अ यूनिट वेक्टर इन दिस डायरेक्शन. यूनिट वेक्टर का मैग्नीट्यूड क्या होता है? 1. तो 1 मिल गया, तो उसको 7 से मल्टीप्लाई करने के बाद क्या मिलेगा? 7 यूनिट्स. सो देयरफॉर विच इज नथिंग बट यू विल गेट इट 7 यूनिट्स वाला मैग्नीट्यूड वाला एक वेक्टर मिल जाएगा. सो देयरफॉर फाइंड अ वेक्टर. सो फर्स्ट लेट a bar is equals to I minus 2j, correct? Now let us find a unit vector in the direction of a bar is equals to I minus 2j. तो इसके यूनिट वेक्टर कैसे निकालते हैं? जस्ट वी सॉ इन एग्जांपल 6, इट इज a bar divided by modulus of a bar, correct? So what is a bar? I minus 2j. But do you know what is modulus of a bar? We don't know. So therefore we will find it. A bar का modulus is given by root of x square plus y square plus z square. ठीक है? So what is x square? 1 square plus 2 square. So 1 square is 1, 2 square is 4, root 5. So answer is root 5. Divided by root 5, what you will get? 1 divided by root 5 I minus 2 डिवाइडेड बाय रूट 5 j. अभी k तो है नहीं तो हम सॉल्व तो करने वाले नहीं, सो कीप इट एज इट इज. नाउ वी नीड, चाहिए क्या अपने को 7 यूनिट वाला वेक्टर. सो वी नीड अ वेक्टर which has 7 which has magnitude 7 units वाला वेक्टर चाहिए था ना. सो देयरफॉर दिस इज अ यूनिट वेक्टर. यूनिट वेक्टर इज ऑलवेज रिप्रेजेंटेड बाय ए कैप. ओके, अगर कैप आ रहा है तो उसको यूनिट वेक्टर बुलाते हैं. दैट्स व्हाई वी गिव कैप्स ओवर हियर आल्सो. ठीक है, दैट इज अ यूनिट वेक्टर, राइट. सो देयरफॉर ए कैप इज given here. So you know scalar multiplication, lambda into a cap we will do. Lambda का वैल्यू क्या रख देंगे, 7 रखेंगे. So 7 into what is a cap, 1 by root 5 I minus 2 by root 5 j. So this is very clear. अंदर मल्टीप्लाई करो, 7 बन जाए 7 by root 5 I minus 14 by root 5 j. Simple sum. Okay. Now let us solve the next example, that is example 8. So here they have asked us to find again a unit vector itself. Unit vector अगर आपके दिमाग में आएगा then the first thing will be a bar by mod a bar. Exactly, a bar by mod a bar. उसके बाद में क्या होगा, in the direction of the vectors the sum of the direction. sum करके बोला है, मतलब ये दोनों वेक्टर्स को हम ऐड करेंगे, उसके बाद उसका एक यूनिट वेक्टर निकलेगा. that we are going to show it as answer. Very simple. So therefore later आंसर कैसे लिखोगे, a bar is equals to 2i plus 2j minus 5k, b bar is equals to 2i plus j plus 3k, cap 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 caps all over. Now sum बोला है हमको. if they have asked us to solve for the sum, it will be a bar plus b bar. दो वेक्टर को ऐड करोगे ना. so you will add I components to I components, j components to j components and k components to k components. इधर I के बाजू में कौन है, 2. so therefore 2 plus इधर कौन है, 2 I को बाहर, plus is there, write down plus 2 plus 1 j. इधर माइनस है then it will be minus, sorry we will write it as plus minus 5 plus 3k. समझ गए. वेरी सिंपल. एडिशन ऑफ टू वेक्टर्स कैसा ऐड करोगे, यू विल ऐड लाइक दिस. सो 2 plus 2 is 4i plus 3j. this is minus 2 plus into minus will be minus, so it will be minus 2k. now this is nothing but your a bar plus b bar. एडिशन करके एक आंसर मिल गया. सो इसका आपको अभी यूनिट वेक्टर निकालने का है. हाउ यू विल फाइंड यूनिट वेक्टर ऑफ दिस. देयरफॉर यूनिट वेक्टर फॉर a bar plus b bar will be a bar plus b bar divided by mod of a bar plus b bar. जब आपके पास सिर्फ एक वेक्टर था तो आप क्या किए, a bar डिवाइडेड बाय mod a bar की. अभी आपके पास दो वेक्टर है, दैट टू इन अ एडिशन फॉर्मेट, देन इट विल बी a bar plus b bar whole divided by modulus of a bar plus b bar. Very simple. So therefore what is your a bar plus b bar, this equation. तो लिख दो 4i plus 3j minus 2k. अभी इसका मॉड निकालेंगे. so what is modulus of a bar plus b bar, इसका ये रूट ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर प्लस z square, correct. हाँ, now it will be root of 16 plus 9 is 25. 25 plus 4 is 29. So it is root 29. Write down root 29, which is equals to 4 divided by root 29i plus 3 divided by root 29j minus 2 divided by root 29k. So this is your unit vector along the direction of the sum of these two vectors. Okay, now let us solve the ninth example. So ninth example, what he is asking us to find is, the first thing he is asking is direction ratios. The second thing he is asking is direction cosines. He has given us a single vector, that is a bar. So let a bar be this, then Now you know that general representation of a vector is xi plus yj plus zk. So whatever is the x, y, z value, that itself is the direction ratios. So therefore direction ratios is nothing but a, b and c, the value of a, b and c, which is nothing but the value of x, y and z. Now tell me what is the value of x here. x का value क्या है 1, y का value is 1 and this is -2. This is nothing but your direction ratios. So first question answered, complete. Now from the introduction video we have seen that cos alpha, that is your direction cosines. Now I will put the heading direction cosines find करने वाले हैं हम, and direction cosines are generally represented by L, M and N. From the introduction video we know that L, M और N को हम कैसे represent करते हैं. So I'll write one, that is L is equals to, I mean cos alpha is equals to x by r bar, and L, M is represented by y by r bar, and L, M और N का क्या है z by r bar. So what do you know, r bar का value क्या रहता है, modulus value. So r bar is nothing but root of इसका modulus 1 square plus 1 square plus 2 square. So क्या हो गया, root 6 हो गया. So this is root 6. Now what is value of L here? L is equals to x is what, 1. So 1 by root 6. M is 1 by root 6. N is -2 by root 6. So therefore direction cosines is nothing but 1 divided by root 6 comma 1 by root 6 comma minus of 2 by root 6. So this is nothing but your direction cosines. Vector joining 2 points is a new concept. So in this concept what we'll be learning is, supposedly you have 2 points, namely I'll name these points as A and B. Now let point A का coordinate is x2, y2 and z2, and point B का coordinate is x1, y1 and z1. Okay, so now अगर आपके पास 2 पॉइंट है और इन दोनों के बीच में एक लाइन ड्रॉ करोगे, एंड यू नीड अ वेक्टर विच इज नोन एज BA bar, इधर से इधर तक. इफ द डायरेक्शन इज इन दिस फॉर्मेट, यू विल बी नीडिंग अ वेक्टर विच इज BA bar. ओके, दिस वेक्टर यू नीड. इस हमारा ज्यादा से ज्यादा इंटरेस्ट किधर है, इन द BA bar itself. Now what I'll do is I'll put this whole junction into this 3-dimensional plane where I'll join OA and OB. OA and OB are position vectors of the vector A and B. Clear? So therefore now this is somewhat looking like triangle law of vector addition. So therefore from triangle law of vector addition के अनुसार what we know is OA bar is equal to what, OB bar plus BA bar. Correct? Now what you know, what is OA? अपना इंटरेस्ट किधर लाया हो रहा है, BA bar में, तो बाकी का सब इधर भेज दो. OB is here. So therefore what I'll do is OA bar minus OB bar is equals to BA bar. My interest lies here. My interest is lying in BA bar. Now what I'll do is, now what is OA bar? OA bar इधर का एक वेक्टर निकाल के छोड़ो. So it will be like x2i plus y2j plus z2k minus what is OB bar, this. So it will be x1i plus y1j plus z1k. Use brackets which is equals to BA bar. मुझे BA bar में interested है. So how I'll get BA bar? BA bar will be equal to x2 minus x1 I plus y2 minus y1j plus z2 minus z1k. So this is nothing but your new formula. This is the formula for, this is short derivation सीखा है हमने. So BA bar is nothing but अगर आपके पास दो पॉइंट है और दो पॉइंट के अंदर बीच में यू हैव टू फाइंड अ वेक्टर, then this is the formula. This is the formula, that is x2 minus x1, y2 minus 1, z2 minus z1. Clearly, now what will be mod of b a bar? Mod of b a bar क्या है? See, tell me, what is mod of a bar? कैसे लेते हो? Root of x square plus y square plus z square. x square plus y square plus z square किधर से मिलते हैं? I के बाजू में जो भी था वो x था, j के बाजू में जो भी था वो y था, इसके बाजू में जो भी था वो z था, ठीक है. तो if you are going to take modulus of this, then it will be root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is nothing but modulus of the vector, and this is nothing but the vector itself. Vector कैसे निकालते हैं? Now let us solve the next set of problem, that is example number 10. This is vector joining the points, 2-point vector joining, and we have to find a vector in the direction of PQ. So therefore PQ bar we are going to find out. Since the direction is given as P and Q, we will be solving for PQ bar. If the direction was given from Q to P, then we would find QP bar. Understand this? Very small concept, but it will help you. Okay, now we have to find the magnitude of this. This is x1, y1 and x2, y2. Everything is already there on the board. Just listen. Formula is what? x2 minus x1, x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. So this is your formula. Okay, just go on substituting. It is like minus 1 minus 2 I plus minus 2 minus 3 j plus minus 4 minus 0 k. So simply it will be minus 3i minus 5j minus 4k. So this is nothing but PQ bar. So this is PQ bar, what we are going to get. If you want modulus of PQ bar, they have not said here, but we will solve it. Modulus of PQ bar will be what? You will not sit applying that whole formula. You will just apply root of minus 3 whole square plus minus 5 whole square plus minus 4 whole square, which will be equal to 3 square 9, 25, 16, which is 34, 16 is root 15. So this is how you take modulus. Okay. Now let us solve section formula. So section formula, will consider a line first. This line segment I will name it as P and Q. I will consider a random point. Let that point be R. Now I will give a reference for this. This is OQ, OR and OP. This is your point O. Let OP is A bar, OR is R bar, and OQ bar is B bar. Clear? So these are your 3 points. Everything remains the same. Next, now consider. In consideration, we will consider it as PR bar divided by ratio. We will consider first PR divided by RQ. We will consider this is PR divided by RQ, and let PR be M and PR be Q, RQ be N. This distance is M, this distance is N. Then ratio of PR and RQ is what? PR is M by N. Cross multiply N into PR, which is equals to M into RQ. Now these are two vectors. Okay, PR and RQ are vectors now. So in vectors, what you will do? N into terminal minus initial. What is terminal? OR minus OP bar is equals to M into what will be this? R and Q is there, no? What is OQ minus OR bar? Now just tell me N into what is OR over here? R bar minus what is OP bar? A bar, which is equals to M into what is OQ bar? B bar minus what is OR bar? R bar. Now what you are going to do is multiply these inside. N R bar minus N A bar is equals to M B bar minus M R bar. Clear? Now whatever R kuta kuta itne, take R to the one side and send remaining to the other side. See, n r bar is here, I'll keep as it is. Here is minus m r bar. If I take it to here, it will be plus m r bar, which is equals to m b bar minus, sorry, the minus hai, then here it will go plus n a bar. Now take r bar common from here. R bar if I take common, this is n plus m is equals to m b bar plus n a bar. Okay, now r bar ka value will be m b bar plus n a bar divided by m plus n or n plus m. So this is your section formula when any random line OR divides the line segment into two parts. One is named as m and another is named as n. So this is your section formula derivation. So here is all the introduction that is about the 10.2. Let us solve exercise in the next video.